go to design and quick layout. And that's my quick layout. It's my favorite one. You know, it's in the chart title, it's all this stuff. I think I'll show this again real quick. It's got all these options, it's got so many cool things, it's so nice.
Gary! I was just looking for the sports channel, Gary.
Hey everyone, let's get Mewbot in here. Am I fading away? Might be fading away. I'm fading away. Getting Mewbot in here. And let's get the chat on the screen, see if anyone's chatting. We're going to do an example question to start. So example question, chat going. And we're good to go. Mewbot's going to, we'll bring Mewbot over there. There you go, Mewbot. You're happy over to the side. And now let's put an example question in here. Where'd the stream thing go? Edit video. What's up, Hayden? You want to do some chapters? Let's do chapter 17 instead. We can do, have you done the full homework yet? Have you done the full homework? We could do the full homework right now. Do that. Chapter 17, difference between two means. Comparing two means. We could do that. Which one do you want to do? I'm so sniffly in this cold weather. Hair's getting so long. Wow. Usually when it gets where my eyes, it's long. But now it's way long. It's long hair. Well, put a question in the chat and we'll do it. Assignment manager. Researchers investigated the size of a glass. Let's do that one. Chapter 17 quiz. Here we go. Replace questions. The size of a glass. Thank you so much, Peyton. I appreciate you being here and asking questions. I'm not even kidding. First question I clicked on right here. I don't know why I wouldn't move over. First one I clicked on, I brought up the questions, and it was literally the first one. So let's grab what we have right here. Researchers investigated the size of a drinking glass. And I want us to think about why this is a two-sample T to start. So this is 253, Stat 201, Chapter 17 quiz. Why is this a two-sample T, Peyton? Why is it a two-sample T test? So to do the two-sample T test, you're always comparing what's. Whenever you do the two-sample T, you're always comparing what's. Remember, it's called two-sample T, and we like to say Mr. T is mean if you're doing drugs. So you're always comparing means. Yep, the T test always compares means. So when you see right here that we're comparing mean small versus mean large, you're seeing the two means are being compared, and we have all the notation right here. So I believe we're running the T test on this, which means we need to do Y bar, and they tell you how to set it up. Let's look at the setup for the question. We are doing mu1 is the large glass. So it's going to be mu large minus, or Y bar large minus Y bar small, because they're sample means, over square root S squared large over N large plus S small squared over N small. Does this make sense, Peyton? We're just going to drag all of these values into here such that we take the means, mean of large, mean of small, and then we make sure to do each one properly. The sample size of small would go here, and the sample size of large will go here. We'll circle that, so it's a little bit different than circle there. And so kind of trying to do it different, like color-coded, but if I'm circling it, it goes with the circled color. So this is the, so that'll be this one. Yeah, that makes sense because I circled the other one. So this is the large mean versus this is the small mean. So that's the small mean. And then we take the value over here. We have the large standard deviation, and that'd be this one. And then we have the small standard deviation, that'd be this one. Does this all make sense right here? Plug in those numbers where they go. And this solves out for a T statistic. This is a T with the complicated degrees of freedom formula. So we're just going to place those values into that equation. We'll do that here in a moment. I'm so sniffly. But the first thing we want to do right here is they're asking, does it affect how much people put in the glass? And so is this a one-tailed test or two-tailed test? We're asking, does it change the portion size? So when you do the tails of a test, this indicates the sign of the alternative. Is this a less than, greater than, or does not equals alternative? Remember, look to the researcher's question to remember which way to do the sign. Is this a less than, greater than, or does not equals? Because we're asking, does it change how much people put in the glass? So is this does not equals, less than, or greater than? The question is, it does not equals because does it change? It's not asking, do they put more in this glass or less in this glass? It's asking, does it change? So that means the alternative will have the does not equal sign. The null has the equal sign. And the mean for this is equal to, which is the null. Oops, equal to. And the alternative would be that they are not the same. They are different from each other. So that's literally where it says mu1 minus mu2 is not equal to 0. There is a difference. Here's where we find the t-statistics. So we're just going to plug in the numbers. Check your math because it's very easy to make errors. So we're just going to plug in all the numbers. It's large minus small, 6.82 minus 5.22 over square root. And standard deviation of small goes on the right. So 6 point, why do they have to reverse the table? Oh, that's not right. That's sample size. I'm going to go sample size here. Helps that I've got the numbers circled. Please tell me if I make an error. It's very easy to make errors doing these. And so that's the orange, 5.82. Look, there's an error. There's an error. Yep. There's an error right here. That is not the standard deviation. The standard deviation of large should be 2.95. It's very easy to make errors doing this. And then this is the sample size of small because we're going right there. So that's sample size of small, or sample size of small right there. Sample size of small is going to be 26. And then we just solve. I always solve out the bottom of the equation first. So we're just going to solve out the bottom first, which is the tougher part of this. The top is just a difference. Really? There we go. That was a weird looking calculator. 2.95 squared divided by 24. So that's that. 1.82 squared divided by 26. And then we add together the two values and we divide. What's it going to be? 0.67? Something like that. No, square rooting. It's going to get, let's do square root. Oh, I said 0.67. I was close. So 0.70, beautiful number because we don't really have to carry decimals because it's very, very rounded almost. And now we just take the top, which is the difference, which is going to be, we can actually do it in our head, 1.6, I believe. And so that's 1.60, which is going to be about 2.28, I think. Let's check it out. 2.29. Okay. So 1.6 divided by 0.7, 2.2857. There we go. There we go. 2.2857, and that is the t-statistic right there. So the t-statistic is this, and and we're around to 2 decimal places. There's the t-statistic. We can kind of guess the p-value. Any guesses of the p-value? Is our final open? It's listed on Canvas. Go to Canvas and click on it, and we can check that next page. And I just don't want to say lest I be wrong. We'll check on Canvas here in a moment. The p-value, I'm trying to think over what the p-value is going to be. It's going to be more than 2% by a little bit. P-value is going to be close to about 0.036 or so. So this is the hardest part of this maybe, is to get the p-value. We need to go to the degrees of freedom applet to get the degrees of freedom right here. So MuBot's going to send us the degrees of freedom applet. So 2 moments right here. Here's the degrees of freedom applet. And then also we need the t-distribution. So we now put in all of our information here, our sample sizes of 24 and 26. So 26, 24, I'm doing them in the order they appear. Sample size 1, sample size 2. And that's the 2 sample sizes right there. And then we do standard deviations 1.82 and 2.95. 1.82 and 2.95. Degrees of freedom probably going to be about 42. No, they're lower than that. 37. So, sorry, Peyton. Oh, you should try it without the applets. It's a lot less fun without the applets. Now you go over here and you have to put in your degrees of freedom. And then we're finding the p-value from t. This also has it on here. You can do the degrees of freedom here also. If you enter in the values, you can get the, I wish I would change it, but you can get the degrees of freedom here too. I always forget that. But now we're finding the p-value from t. So now we want to do the outside because this is a does not equals test. If it's a less than test, shade to the left. If it's greater than test, shade to the right. If it does not equal, shade both sides. That face painting's cracking me up. And now we enter in our t-statistic, the negative version and the positive version, and it's 0.03.028. So I was close. My guess was close, but it's 0.028. I would have been too far off, 0.028. How are we doing on this, Peyton? That might be some of the hardest steps for people because now we've basically done the question. Do we reject the null or not reject the null? There's the alpha level. So do you reject the null or not reject the null? The p-value is 0.028. Do you reject the null or not reject the null? Because the p-value is 0.028. So what do you do there? And the alpha level is 0.05, which is classic alpha. Reject, p-value less than alpha, reject the null. Since the p-value is less than alpha, you reject the null. So we reject the null. There is evidence, so the data provide evidence that there is a different amount in the glass, different from, we should be at 100. Yeah! I always get a little bit afraid. I'm going to make some math error. But you just have to be very, very, very careful and very, very, very exact with all your calculations. That is one of the tougher ones, doing the steps and then knowing how to get certain things like the t-statistic, which comes from this equation right here. There's the t. We then use the t-statistic on the right curve. In July, you got it. Let's do that one next. In July. Let's do that one next. Ooh, that one's... How are we going to do that one now? There's a lot of ways. In July. We don't use jump now. Ooh. Oh, we got this. We'll crush this one. Get ready for another one, Peyton. Drop another one in. Copied question top area. Have another one ready because this one's going to go quickly. I'll try to expand upon it and teach something on it. Okay. So we are at the 13 mark. Okay. So in the July 2007, nice. That one's a little longer. I know that one. In the July Consumer Reports, we have people looking at different types of hot dogs. We got a mixture of meat or all beef hot dogs. The researchers compared different brands. The meat hot dogs had 117, 111, whatever calories. The other ones had 135. A test of the null hypothesis that there is no difference. So the null is that there's no difference in the calories because we're comparing the calories in these hot dogs of all beef versus different meats. Yields a p-value of 0.12. Well, wait a minute. 0.12, reject the null or not reject. What's the, oh, do you know, it's been, Roto, you're cracking me up. We got a Roto wave bomb in here. So with this in mind, what do you do with the p-value of 0.124? Reject the null or not reject the null? Roto should know this. Reject the null or not reject the null? P-value 0.124. Reject the null or not reject the null? What do you do with that high p-value? What do you do with that high p-value? It's a really good quick question. Yeah, Rhoda's like, you got this, Peyton. Throw the football, Peyton. Say throw footballs, right? You do not reject exactly. It's a high p-value. When the p-value is high, you do not reject the null. And the null is that there's no difference. So would the interval contain 0? Because you're saying, I don't reject that there's a difference. So think about an interval to say, here's what we think the difference is between the calories. Interval A says, I think the calorie difference is somewhere between 12 through 30. Interval B says it could be up to -8 all the way to like positive 20. Like the difference is somewhere here. Randomized, good to see you. Thank you so much, Randomized. Good to see you. Throw randomized some points too. So which of these sounds more like we don't reject that there's no difference? Interval A or interval B? Because no difference means 0 is a possibility. If we're saying I don't reject that there's no difference, because you'd have to look where 0 is at. So 0 is this value. 0 would be down here. And then in this interval, 0 is here. Interval B contains 0. So it makes sense if we don't reject 0. Like 0 is what we're saying. I think there's no difference. I don't reject that there's no difference. So the interval would have to contain 0. How's this making sense, Peyton? We would not reject it. So would the interval contain 0? Yes. So the high p-value means that, no, the high p-value means we lack evidence of a difference. So 0 is a plausible value. Yeah. So it means it's plausible. 0 is a plausible value. We would not reject 0. That one's very, very similar. I want to do the sugar cereal one because I have to find a different way. That one's a classic one. That route question there, everyone, that's a usual one for the semester. Core Plus Mathematics. I think you're doing all the ones on your test, right, Peyton? Peyton's like, I'm going to get 100. If you're watching this right now in the background, drop your questions in. Get 100 too. I do have a lot of these in other videos if you're watching this. You can find pretty much any question we've done, but you get to ask your questions here and I get to quiz you, which is even better. Okay, Core Plus Mathematics. We start out with what are called the summary statistics at the start, the sample sizes for each group, the sample means for each group, and the standard deviations. What I would try to do if you're doing a question like this is to know your notation.
Notation,
You gotta know
brother.
the notation, brother. And we go right here. And immediately, some of this is marked properly, but you want to note this is sample size, this is Y bar, and this is standard deviation of a sample. And they should tell us which one is group 2 and which one is group 1. They do it right here. Core Plus Mathematics is group 1, and then the traditional is group 2. Which of these is not a plausible answer, and tell me why? I want you to look at the way these nulls and alternatives are written. Oh, you have another one? We'll do this one real quick right here, and then we'll do the other one. We should be able to get this one done 5-6 minutes. Which of these is not a plausible null? Answer that, and then I'll give you the right answer. C isn't, because the null always has the equal sign. So you notice they're doing the greater than, not equal, or less than. So we have to look at which way they're testing. So they want to see Perch teaching mathematics. Wait, do they... So they never mention if they want to see if it's better or worse. So that means they're doing the does not equals test. Unless I'm missing something. Yeah, that was my question right there. C was a not plausible answer because it has the not equal sign. That's not the way the null works. And Peyton, am I right that I don't see any sidedness? Like, is Core Plus Mathematics better? Which is the only one I think they could be going for, which would be this one. This would be because it's a greater than like 10 minus 8. It's not 10 minus 8. But I think the answer is B. I'm a little worried. But I don't see any sidedness on this. As in, like, they're not saying, let's see if Core Plus Mathematics is better or worse. They just want to see if there's a difference right now, which would be B. How does that look? I think that's right. Problem is if we make a mistake on the null and or the alternative, we get the p-value wrong, because the p-value is going to be based. We're going to shade it based on that. So Core Plus Mathematics. Good morning. Oh, Mubot's here. If you say good, he responds. Core Plus Mathematics is the first one, so we have to do mean of Core Plus Mathematics minus mean of traditional over square root of sample size or standard deviation of Core Plus squared over sample size plus standard deviation of traditional squared over sample size. And so now let's plug these numbers in. Please tell me if I get something wrong. 57.39 minus 53.86. The difference over square root. And we do standard deviation of Core Plus 32.09 squared over 320 plus 28.54 squared over 273. So the bottom of this is the standard error, which we're going to solve for. We're solving this bottom part. And so 32.09 squared divided by 320 square root. Oh, wait, am I doing? What am I doing? 32.09 squared divided by 320. Good. And then 28.34 squared divided by 273 plus the other one. And then, so we just added them. We literally have the quantity right there. And now we need to square root it. And the answer is 2.419. 2.4819. And now we take the difference up top. The difference up top is going to be, I'm going to copy this. 57.39 minus 53.86. So 3.53. So we should get like 1.4 or so. 3.53. And then we're going to divide these numbers. Divide by that lower number. Really. 3, I copied it apparently. Divided by 2.4819. And 1.422. Okay. So this is a two-tailed test. And the p-value has to be somewhere between 20 and 10%. Probably more like 14%. Let's go copy this. There it is to 2 decimals. My guess of the p-value is going to be 0.1438. And now let's go find it. So we already have in here the degrees of freedom it's given to us. Very high degrees of freedom. So we're going to go to the T distribution, which MuBot is dropping in the chat for us. And when we go over to the T distribution, we have to enter in those degrees of freedom, which are 5. We could enter in 590 at this point. Well, if you want to be very particular, 589.966. And you'd have to find this via the applet over here, T's degrees of freedom, if it didn't give it to you. We can't test you on that, but you have to use technology these days. We enter in the negative version of the t-score and the positive version because we're doing the two-tailed test. The p-value is 0.155. I was not too close, but not too far off. And now what do I do, Peyton? Reject or not reject? So alpha level 0.05. So reject or not reject? Reject or not reject? If we make a 60 or something, I'll know why, but I think we're good on this. P-value is 0.155. Do not reject. P-value is higher, so I do not reject the null. Fail to reject. There is not evidence of a difference. So I think we're good. 100. There we go. I was worried about the sidedness. If it had been a greater than test, don't do this. This is the greater than test. It would still be the same T statistic, and this P-value would be cut in half right here. The 0.155 would be divided by 2. We'd still reject the null. But when we set up the test, we would do the greater than test and do the above, and you'd enter this right there. So that's how we got the thing, cut the p-value in half, and you can see there it is right there. That was not required, but I was a little worried, but they didn't give a directionality to the test. Let's do another. Here it is. I think we're good. Ooh, we got this one. So this is the test one. And it looks like this is the one you have, right, Peyton? Is this your version? This is the Core Plus Mathematics confidence interval version. So confidence interval. Okay. Confident. Okay. So if you notice, they give you an interval here, and the first thing they ask you is, what is the margin of error? A lot of people have a lot of trouble solving the margin of error. But if you get an interval, I want you to try solving the margin of error without actually doing some real mathematics. So what is the margin of error of this top interval right here? So Payne, look at this interval from 12 to 30. What is the margin of error? From 12 to 30, what is the margin of error? Be very careful. You might, it's not 18. It's not 18 though. From 12 to 30, what is the margin of error? I'm going to draw some visuals right here to help out. And I want us to think what the margin of error is. What is the margin of error? What is it, man? That is the margin of error visually. And the margin of error can always be expressed as a plus or minus. So what is the margin of error here? It's 9. You got it. It's always half the length of the interval. So if you take the upper minus the lower 18, the margin of error is always half the length. Does that make sense? Like 18 is the length of the interval, upper minus lower. So 21 is the center of the interval. If you average the two numbers, you can just take 42 divided by 2, like add them together. So it's half the length of the interval. So the formula is upper minus lower divided by 2, which is, this is the length of the interval. So upper minus lower is how big is the interval, the range of the interval, and then you divide by 2 to get half the length. If you were to add these, you would get the center of the interval, because then that takes the average of the interval. It finds the middle of it. So all we need to do here is just take these two numbers and subtract them. Yeah, exactly. It's once you realize it, like you're like, oh, wait a minute, I'm just seeing how far these numbers are apart. They're a little less than 6. So truthfully, if it's, is it 1 decimal? 4 decimals. It's gonna be close to 2.9. I think this question used to be like 1 decimal. So upper minus lower divided by 2. And there it is. So just say 4 decimals? It doesn't even give us 4 decimals. Oh, because this they end in the same decimal, so it rounded to 0. So there is a 4th decimal technically, but okay, there we go. If you were to make a 98% confidence interval, well, this is the ones we do with our hands right here. So we're at 95. If I go to a 98% confidence interval, what happens? So if I go 95 and then I say 98, I need to do what with my hands? Like conceptually and visually speaking, going from 95 to 98 would do what? Like this happens when you make an interval more confident. It always gets wider. You go 95, 98. It gets wider. Because think like you're more confident. Because you'd say like, oh, I'm only 10% confident I'll be here between this window, but I'm 90% confident I'll be here between this window. 90. No, don't worry, Payne. We'll throw you some points here. So The margin of error would be larger because the critical values are going to be bigger, because the critical values are the t's we use, and we can see it here visually that when you make an interval, you go to the between, and we want to find the t using the p-value. So if you notice right there, that t statistic, if I make it less confident, gets smaller. But if I make it more confident, the t gets wider because you cover more areas. So this is what I'm saying when I say like 68, 68, 95, 99.7. You go further and further out and cover more area because you're more confident that the truth is in there. Explain what calculating the interval means with 95% confidence. It's going to be the average student because we're doing it for the mean, not an individual. Using, because they're talking about the difference right here. Since the difference is positive, they're doing mu of this minus mu of this. You would have to think right here that there's about an 8-point difference because 8 is at the center of this interval. So when the difference is positive, that is evidence the first mean is higher. So with this right here, imagine this is Brian minus Darren in basketball. And we look at how many points on average we get in a game. So this is Brian's average points and Darren's average points. And with this, we see an interval that goes from -30 to -40. Does that mean someone's getting negative points? Does that mean someone's getting negative points? Doesn't make sense, does it? No. It means that when we did this, apparently, Darren might have got something like, this is like fake numbers here. I'm just making this up. You wouldn't be able to solve this right away. Darren might have got 40 points in a game on average, which is awesome. And I might have got 5 points. And you know what's interesting? The difference of 35 is at the center of the interval. And then this is the estimate of the true difference. So we observe a difference of -35 points just by the way we're doing the math. Does that make sense? We saw a difference of -35 indicating Darren got on average more points, but then we estimate Darren gets somewhere between 30 to 40 more points because since the difference is negative, it sides with Darren. Now, our interval is positive, and since our interval is positive, that means the evidence the first mean is higher. If the interval is negative, so if there's a negative interval, that's evidence the second mean is higher. Peyton, does this make sense? If the interval is positive, that is evidence the first mean is higher, because that's, you'd be subtracting like 15, well, I can't do it that way. Yeah. So it'd be like 15 minus 7, because that would have a difference of 8, and 8's right there at the center of the interval. So 8 would be your best guess of the difference, but then you'd go plus or minus a certain amount. That's not the true center. So we think that the CPM method is better because the interval is completely positive using the traditional method. That should be right. The results says that students who learn the CPM method have a significantly higher score. What numeric difference would suggest no difference? What mathematical difference would suggest no difference? Like if we saw a difference of what? It's kind of entailed in the question. It's not meant to be tough. What mathematical value would suggest no difference between the students? 0. 0 is not in the interval. So the results do suggest a difference because the interval does not contain 0. It only contains positive values, which suggests that the CPM method is better because there's a positive difference. We should have everything right. 100. That's a really good one. It's a very good conceptual one. I might drop another one, Payne, if you have one. I guess we got to do this one in Excel now, which I might do this one real quick while you think of another one. But we used to do this one with Jump. Might be able to just drop it into Excel. This one could be a joke now. Maybe it is. Maybe it's not. We'll find out. A pharmaceutical company. Let's do that one next after this. So we'll find out how much of a joke or not a joke this question is coming up right here. The data below shows the sugar content. And so we're going to copy this data set, go here and copy to clipboard. And we're going to copy it with Control-C. Now we're going to go into Excel. Excel opening up. Okay, 2 sample t-tests. We just paste the data in. Now, there's the easy way and the longer by work way. Let's hope it just does it the easy way. So with our data and data analysis, let's hope there's a 2 sample t-test on here. Okay. Okay, here it is. T-test 2 samples assuming unequal variance. That's actually what we've been doing this whole time. The test is difference if you assume equal variances. So we're going to go select the t-test assuming unequal variances and click OK. I think we got this. This is going to be nice and easy. Cross your fingers. All right, so the way they do the test, let's look at it, is they don't tell us, do they? Oh, children minus adult. Okay, so very important right here. So we need to take children's values first, drop down to adult. I'm holding shift. Click in range 2, click up the top cell, and then hold shift, click the bottom cell. And so that's got the values. Hypothesized difference, we could just put in 0 for right now. And we do have an alpha. Let's put labels are in the first column. And new worksheet. Let's hope it gives everything I want for this. It's going to do a test, which is okay, but I want the interval. And here we go. What did it give? It might not have given what we needed. Well, darn. Oh, boy. So, we have a small issue. It's not that bad. It did the t-test, and there's an obvious evidence of a difference. We have the means right here, and we have the variances. So what we could do is we can actually we can create the confidence interval. I wish it did everything for us. Let's go get the standard deviations. And let's go get, and you can find these all on the same page if you want, but I'm going to put everything here nice and neat. Standard deviation for children and sample size for children. And we could also get, and we'll do all the work on our own. Here we go. So, oh, it's already got observations. Let's call it sample size. There we go. So we just need standard deviations and we can do the work. We're literally going to solve the formula of y bar children minus y bar adults plus or minus the t statistic with the very interesting degrees of freedom, which it gave the, wait, that's not right. Can't be right. But I did unequal variances. Are the degrees of freedom that perfect? Well, maybe they are. Then square root s sub children squared over n sub children plus s sub adult squared over n sub adult. There we go. So we're going to solve this formula right here, and we just need the standard deviation for children. So let's type equals standard deviation right there, and then we go back to the original sheet. We grab the data, and then we close it off. And there's that value right there. And then we go over here and we type equals standard deviation, and we're going to go back and get the data for the adults. And we click adults right there, and we scroll down, we hold shift, and then we close the formula. And there's the standard deviation for the adults. We're going to check the degrees of freedom real carefully because I did the unequals, I thought. Should be assuming unequal variances. And let's go check this. To check this, we're going to go to the 2-sample t degrees of freedom calculator, so TDF. And we're going to put in our sample sizes of 20 and 30 and the other numbers respectively. So this will make sure, and we'll change the degrees of freedom if it comes back with the wrong degrees of freedom. Oh, TDF. T degrees of freedom. Oh yeah, Ubot's going to pull that up right here, which I already have it open on this screen already, I forgot. And let's bring this down here to where we can type it in. Okay, so, really? This is just barely going to be off the screen. There we go. So sample size is going to be 20 and 30 respectively, and then the standard deviation of 6.923, and the standard deviation of 7.684, and the degrees of freedom are, oh, look at Excel rounding this. So it did it. You're probably fine. So Excel looks to have done it because it makes sense. That's not sample size -2. Excel's just not carrying decimals, which, come on, Excel. You might have to... Nope, it didn't carry decimals. It's probably good enough, but I'd be worried if, to me, that's a little bit of an error. So 43.71. With this large of a degrees of freedom, it's probably not going to make a difference on the decimals. So not that big of a deal. Did it already change my number back? I don't know. There we go. So you're probably fine on this, and I'll show that. I'll actually use 44 just to prove the point that you're okay. It would really matter if it was something like 4.23 or something. Then that would matter. Those 2, 3 would matter on those small numbers. So now we have to go and get this t statistic for a 95% confidence interval, I think it said. 95% confidence. We need to go get the t. The t is going to be about 2.04, and we could actually go put that t down here and actually give it to us down here. So actually, if you got 95, they're showing you the t right here. That is the t. So let's put t statistic. Don't use the, or wait, t critical. The way they describe these, I wish they were more of the one-tailed. The way they describe it. Let's just put our t statistic here. It should be around 2.04 or so. Let's go grab it. So to get the t statistic, we need to go back to our applet, and I'm going to drop it in the chat if you're not seeing it. So here's the t applet, and we enter in our 44 degrees of freedom. We go to 95% between, and it's going to be basically 2. And there it is, 2.015. So we have confirmed by doing this, 2.015 is the t. It's this value right here that you could actually use. So it actually, and that's only for the 95. If it gives you a 98 or something, you will need to change this to 98. And you could actually do it when you were doing your test. You could have changed this here. So I should have mentioned this, but you can go right here to data analysis, and when you rerun it, if you enter, if it's like 98, you could change this to 0.02, and then you would have your answers basically. I don't know what it's mad about now, but it's mad about something. T-Sys input range contains numeric data. Oh, I think I added something or something, but you could change the alpha level right there. So let's hit cancel. Okay, so now we just solved the formula. The problem is now plug in the numbers. So children's cereal 46.6. Plus or minus. Standard deviation 6.923 squared oval 20 plus 7.68 squared over 30. It's just a bunch of math. That's always the fun part. 6.923 squared divided by 20. And then we need to add to that 7.68 squared divided by 30 plus the other one, square root 2.089. Really? 2.089, 2.015 times that. That is the margin of error over here. Once again, make sure you know your components of a formula, that everything after the plus or minus is the margin of error. This is the standard error on the far side of the equation. That's all the standard error, and this gives you the confidence level right there. So we're going to multiply those together to get the margin of error. And 4.21 is the margin of error. And then we just subtract here to get the center of the interval, which is 46.62 minus 10.11, 36.51. Why is that still on screen? 36.51, 36.51, and then you add and subtract on the interval to get the upper and the lower. So the upper is going to be 40. We're just adding these numbers right there, literally just adding them. 40.72, and the lower on the interval is going to be 32.30, I believe. So double check your math. Excel errors never tell you what the problem is. Yeah, I probably took 10 years off my life doing one part of the project. Oh no, I know. It's like the errors are just like, check version B. And you're like, version B? What are you talking about, Excel? And it's like, version B not acceptable. And you're like, what is this? 32.30, 40.72, and then we are confident that the children's cereal has this much more sugar than the adult cereal. So 32.30, 40.72. Let's hope we did all our math correctly. Check answer, 100. Yeah, it's a good problem, and it shows you what you can do with Excel pretty quickly. It's just getting these summary statistics that's important. You just need the mean. I mean, just think how every problem we solved has been find the mean, find the standard deviation, find the sample size, find the t. Does that make sense, Peyton? Like, all I'm doing is just getting the necessary components to enter it into this equation. So you have to know, like, mean 1. I didn't put bars on the y. It's y bar. That would just be an observation. Now it's a mean. But y bar, children, cereal, sugar content. I had some sugar cereal. Yeah, just find the values for the equation. That's some of the harder ones. Let's try to get another tough one done. This one's easy. Let's do an easy one. Let's do a tough problem. Let's do an easy one. Yeah, that one took 12 minutes. That is a tougher one. It's just a lot of steps. It's like you gotta find certain things. Okay. Easy problem. No crashing out. Okay. Oh, you said this one, right, Peyton? Didn't you say a pharmaceutical company? I think you said this one. Yeah, it's producing and marketing. Ginkgo biloba. Supplement to enhance memory in an experiment. So they ran this experiment. Oh, you have the other one? We'll do the other one next here. 2-sample t-test was done. The p-value was... Is that their p-value? What are they? Oh, because they're doing a greater than test. So their p-value is 0.9378. Very, very what p-value? High. So they're almost the same. Cool. Might be a different version of this one too. So if you notice, their p-value is very, very high, which means they don't reject the null. Explain the p-value means there's a, this sounds correctly, there's a 93.78 chance of seeing a difference in mean score this large or larger. That looks about right. If the mean memory scores for ginkgo biloba and people not taking it are the same, if there's no difference, that's the null, then there's this probability. So given the null is true, there is no difference. So the observed difference would occur, or one larger, because we're testing for a greater than difference, 93.78% of the time. So it's very likely to see something like this or larger. State your conclusion. P-value is high. Don't reject the null. Since the p-value is so high, there is not enough evidence, I would say, but this looks about right. Since the p-value is high, there is no evidence that the mean memory test for ginkgo biloba users is higher. I would probably say there's not sufficient evidence or not enough evidence, or we lack evidence. So that would be good. Now, here's the thing. So is it type 1 or type 2 the only error we could make? So think of what we did. We failed to reject the null. So we've only opened it up to a possible what error. This is a really great question. We failed to reject the null. So it's only possible, if you know my tricks, you can get this pretty quickly. It's only possible we've made a what? Like, not saying we've made this, but the only type of error we could have maybe made is a what error. Yep, because in a type 2, you fail to reject the false null. So the 2 is associated with an F. So if you know this trick right here that we do, in a type 1, the null is true and we reject it, that's the error. In a type 2, the null is false and you fail to reject it. Since we failed to reject the null, the only possible error we could have made is a type 2 error. Yeah. So, yeah, it's really good right there. If you know the tricks, you can sometimes get things pretty quickly. You're like, well, we didn't... Do consumers spend more? Yeah. Oh, this one's a very math. This one's easy, but it's... A lot of people get stuck on that one. It's just math. Suppose an experiment was done. Which the following alternative test for the freezer method less fewer. So freezer has less on average than counter. That'd be it. There you go. What do these order independently? Wait, 2 groups are independent. That sounds right. Really? Let me read the question. Which of the following is not appropriate? 10 successes, 10 failures, because that's success failure. Cool. Okay, where's that Walmart? They were like advertising for Walmart. Here we go. Walmart or Target after Black Friday. I should read the question, right? Be a good idea. Like, actually read the question. Then you can see. I thought I was asking what is the condition. I should have looked and saw there was multiple right answers, like randomly drawn, less than 10% of the population, and yeah, success failures for categorical data. Do consumers spend more, Walmart or Target? So Peyton, you know what it is.
Notation.
Time for notation. You have to look at the way the test is being done. Do they make it clear in this problem which group is A or B? This is where I get so angry, because we're going to find out the hard way. But usually you assume they do it in order. I think it's actually reverse alphabetical order. Oh, no. I can find out very quickly which way they do it by the T statistic. We're going to take a quick look. I think it's supposed to be, I swear it's Walmart minus Target, because it was children minus adults. So I think usually T statistics do reverse alphabetical order. So you put the, I don't know why they do that, but here we're just going to look at the completed problem. I'll tell you why. No, they are doing it Target minus Walmart because the T statistic is negative, and this would be a p-value of about 0.001 or so, 0.02. So they are doing Target minus Walmart, and that's very apparent. And they're also checking for a difference if any exists. Okay. So now that we know it's Target minus Walmart for certain, so they are doing mu Target minus mu Walmart. I wanted to check that because I'll outthink a question. I'll be like, well, usually they really need to say in a question, test the difference that between Target minus Walmart. Does that make sense? So we're interested in the difference of Target minus Walmart. They should state that. And now all we have to do is what, Peyton? Plug in the what? You know it, you love it. So y bar Walmart minus y bar Target over square root of standard deviation Walmart squared over sample size of Walmart plus the standard deviation of Target squared. Write these equations like 10 times, you'll get them down. Over the sample size of Target equals ET with the complicated degrees of freedom formula. This is what we're solving for. Well, what we're trying to understand. And now we just plug in the numbers. So plugging in the numbers, we get 45 minus 54, which is a difference of -9. We're going to divide this by the standard error. The standard error is going to be Walmart. Wait, what am I doing? Oh my gosh, why did I do? I literally said we're not doing this. What is my pen doing? Okay, so Target, Walmart. I set it up right over there because it's Target's over here. Okay, so now we have standard deviation 21 squared over 81 plus 79 on the bottom for the sample size of Walmart over 18 squared. Okay, well, let's do it. So now we're going to solve the bottom of the equation. 21 squared divided by 81, that's that. 18 squared divided by 79 is this. Add them together, divide or square root it. So we're going to get about 3. I should have known that. 3.09. Ooh, 3.09. And then we're just going to solve this. This will give us the t right here. So that is the t. So the t is about 2.91. -2. 2.91. So 2.913. So the t is equal to -2.913. And so, yeah, that's the t statistic. That is the standardized difference. We were testing to see if there is a difference, so we're using the does not equals alternative. To 2 decimals is going to be -2.91. And that makes the p-value to 3 decimals. Now, here's a trick. Remember we just saw that the last one for 3-something was like 0.002? So that means this one needs to be a little bit bigger. And if you use the 68, 95, 99.7 trick, it has to be a little bit bigger than probably about 0.003 or so. We can find the exact value in a moment, but I would say it's going to be very close to that. So here's how you find the exact value. The degrees of freedom are given. So we're going to go and we're going to enter in 155.45 degrees of freedom or so. And then we need to go to the outside test and put in find p-value. So we're finding the p-value, which is shade to the outside. And then we're going to take our t-statistic here and do the negative and the positive version of it. And I was a little bit off, but it's 0.004. 0.004. So I was a little bit off right there. And so the p-value is low, reject the null. Since the p-value is low, reject the null. There is evidence for the alternative that the means are not equal. That should do it. Check answer 100. Yeah, so we were rocking. I only got one wrong. It was when I was clicking on not even reading the question. But Peyton, is this making more sense? It becomes like a lot, like when you see this, like based on this information, can we conclude that women are on average higher? No, because 0 is in the interval. How did I know the negative? Oh, for this? So how did I know the t-statistic was negative? I cheated by looking at the right answer, because when I looked at the right answer right here, I saw that I was only going to show mine. So when I did, and it was a different version, it changed the version when I did it. I saw that the difference was negative, which means they have to be doing 45 minus 54. Does that make sense? They should have said it. But because, how do you know, how did you do the negative and positive? Oh, on the applet. So you need to go to the outside. Find p-value using t and shade the outsides. So you go find p-value using t, enter the degrees of freedom to give the shape of the t, and then click on the outside, because below is used for less than, above is used for greater than, and outside is used for the does not equals test. So the outside shades the outside of the curve. Like if you go -2 and +2, you'll get about 5% outside. So is that making sense right there? So you got to click the outside to do the does not equals test. Let me mark this, and I'll probably head off. When you're clicking between these tests right here, this is the greater than alternative, this is the less than, this is the does not equals, and this is confidence intervals. So the between is when you make a confidence interval right here like this. The outside is when you shade the outside of the curve, and then the below is when you shade the less than, and the greater than is when you shade above. So this is a greater than test, this is a less than test, this is a confidence interval, and this is a does not equals test. So just knowing which button to click, when you click the outside, you get those, and you have to enter in 2 values. It should almost assume the same values, but yeah. I think that's got it. Any other quick questions I can just destroy? Oh, it still keeps my other completed problems, right? Let's look. Oh, this was bigger. Wait, be pretty. Oh, there's the interval. The interval's negative. So the interval's negative, so it looks like Walmart is higher. So the difference between them is about this, with them purchasing more of the purchase amount at... Wait, what? The mean purchase amount of Target is between this. No. With 95% confidence, the mean purchase amount of Target and Walmart is between this more than the mean purchase is at... Yeah, more than Target. What? Let me see. Walmart, with 95% confidence, the mean purchase at Target and Walmart is between this. Oh, it's Target is this much... I wish they just said more than Walmart, because the interval is negative. Sports Porter, let's try to do that one real quick. You ready? Let's do it. Sports Porter. We got just enough time. Let's do it. I wish I could just like say the answers out loud and they would just be like, that's a good answer. Probably doing it soon, right? Wow, we've done a lot today. Here we go. Okay, so we get the notation. We got to run the test here, Peyton. And this one hopefully says, look, let mu1 be baseball players. So it does go in order. So all we're going to do is take all these numbers and plug them in where, Peyton? Let's destroy this question. Let's do it. It's the multiple choice one. Oh, man. So if you got this one right here, plug it into the thing. And suppose an experiment. That's not it. Sports Porter. Here we go. Okay, so we have an interval. Does the interval contain 0, Peyton? Does the interval contain 0, yes or no? Just yes or no in the chat. Does the interval contain 0? Does the interval contain 0? It does. If the interval contains 0, that means we do not have evidence of a difference. So as soon as you look at an interval, it could be that there's no difference in, I think, the age of these players between sports. So we don't have evidence of a difference between them because the interval does contain 0. And so now, with the interval containing 0, we are 95% confident that, so the negative would be football players are this much older. So let's see right here. This, like some of these, we are confident that no. There's a 95% chance, no. The interval of, it's probably going to be this one. We are 95% confident that the mean age of baseball players is between this many years younger, because football player would be older for the negative part, and this many years older than professional football players. That should be right. I am 95% confident that the true difference in the means between baseball and football players is contained in the interval negative 0.092 to 3.432. So just think about our interpretations. Like we are sounds a lot like I am 95% confident that the true difference in age, mean age of baseball players is contained in the interval. And then it could be anywhere that football players are up to 0.092 older to baseball players being 3.43 higher. Because remember, the positive number goes with the first one, and the negative goes with the second one. I think we did all the easy ones, right, Peyton? Oh, wait, this one right here. So since both numbers are negative, we can reject. So if both numbers are negative, it looks like, so the second mean would be higher. Counter leaves more unpopped. So it looks like there's evidence counter is larger because both numbers are negative. Yeah, actually, we just did this one. We just did that one, right? Both numbers are negative, so we just did that. Did we just do that right there? Since both numbers were negative, there's evidence the second mean is larger. And we did almost all of them today. Look at this. I'll do this one really quick here. It was the other one? Okay, wait. I gotta have it in a moment, but let's see. Am I missing it, Peyton? Or did I already do it like quickly? Is it 6? I might have done it already, Peyton, by accident. Okay, let's go. Tell me which number it is if you see the number. It's supposing experiment was done with unpopped popcorn kernels. I think I did it really quickly. Like, I think I saw it and I did it. Find it. I'm trying to get as many in this video. Is it this one? Yeah, like, so they want to see which of the following is an appropriate hypothesis to test whether the freezer method left fewer. So freezer less than counter. Yep. So because you're going to say the true average of freezer leaves less than the average of counter on average for the alternative. No worries. I do a lot here. I'm glad you're here. I want people here. We can do this. Let's see how fast we can do this one. You ready? Last question. They paid Naomi the 50,000 points. I said I was going to give that out during all these office hours. So let's give out the last 50,000. We might have office hours. We should have office hours tomorrow. Been a busy day. A lot of stuff. If we look at the p-value right here, the p-value is high. What are we trying to test? We're trying to test probably if there's a difference. So researchers collected. Let's put it in the video. Someone's be like, oh man, I was going to do this problem, but it wasn't in the video. So researchers collected. The question first is, what is the sign of the alternative? So researchers collected samples of water, and they measured the acidity level of this. The plot on the right shows it. I think they're just testing if there's a difference, right? Yeah, they had to have tested. Well, wait a minute. They should be very clear on this. They seem to be testing the alternative. Well, here's the thing. It's got to be this, because this is the only one that has the equal sign on the null. So it is that they're testing for a difference, because these are improper nulls. So that's the proper nulls. That makes it very easy. Which assumptions do you have to, which appear to be met? You have to have independent groups, randomization. They call it randomization sometimes, and the data needs to be nearly normal. The p-value is very, very high, so we fail to reject the null. There is not evidence of a difference. Check answer, good to go. Well, we did all but like a few questions right here. Could we get this one guessing it? Okay, so I only got a few minutes. Does it change the size of the portion? So it's going to be does not equals. Okay, so the difference in means is about 1.8. So I'm going to guess this is a big, and are they doing small minus large? I don't even see which way they're subtracting them. For anyone watching, they are taking large minus small because the difference is positive. So they're taking large minus small. So you have to do 6.78 minus 4.97. So there's that. And let's go for an easy one to get 3. And the p-value here would be about 0.0. Sure. And that means we reject the null. So reject the null, there is evidence of a difference. 50. It means we missed these in the middle. So those would be hard to guess, the p-values. Make a 95% confidence roll. I can get this one real quick. You ready? No, we got it out. Okay, let me think. I'm going to literally try to do this one in my head. So they want B minus A. The difference is 4 minutes. And then he does each route 10 days. Standard deviation of 4 and a standard deviation of 1. So 16, 7, 17 over 10. That's 1.7. Square root of 1.7. 95% confidence roll. 1.7 square root. So what would you square? About 1.4. 1.4 times 2-ish is about 2.7. So should be about 1.3 to 6.7. So yes, because the interval contains it. Oh, man. How far off was I? Might not be able to get it. What's up, Maddie? Good to see you here, Maddie. We're about to head off. We've done a lot of this quiz. I'm trying to guess this one. I might not have been close enough. Darn it. I thought maybe I needed to go lower. There it is. Okay, so now I can figure out the answer. Because I know the center of this interval is 4. So it'd be 4 minus 2.88, which is 1.12. There we go. There we go. We got it. My guess was this, which is pretty close. I bet I can find that. Let's drop that in the video. We didn't do it this semester live, but it's due tonight, right? I'm gonna have to run to class right after I go run. Okay. go find chapter 17 homework. Chapter 17 homework. I bet I got it here. Look at this. Look at this. Shorter hair, Brian. I think this is the full homework. Hopefully we didn't do much jump. There we go. So there it is. It's all a lot of by hand work. So here it is. Copy video at current time. So homework help. And there it is. And I'm going to email these. Can I go on Cambridge? There you go. You're welcome. Thank you for asking. All you have to do is ask, and I will try to help. And let's send these out. Homework and quiz help. Oh, gotta log in. Gotta log in. Got minutes. Are you trying to log in? Yes, I am. Woo! You're welcome, Peyton. Thank you so much, Peyton. Peyton, I really appreciate it. You've been doing an amazing job. These are tougher chapters. Take a lot of practice. And I totally understand. Let's do chapter 17 help videos. Homework. And there's that. And quiz. And we'll drop today's office hours. Live stream from today's office hours here. Just watching the past money. There we go. And let's publish. And we're good to go. Got to start working out again. One of these days. Fine. Gonna start doing it. Get strong. One of these days. Come on, Brian. Start working out again. Bye for now, everyone. Bye.